Okay, Aubrey and Carson, we are doing 7-5, rhombus and square. We filled these two boxes out on Friday, but I don't think I recorded them, so I'm going to just real quick go through this. Okay, if you guys have this paper, get it out. Let's test our knowledge, see if we can remember a rhombus. I remember him as a tilted square. Yeah, sideways square, okay? A rhombus is a parallelogram. So all of the 5 things from up here that you have already filled in also apply to him. What's true about the sides of a rhombus? All sides are congruent. So he is a tilted square. What about the diagonals of a rhombus? They are not the same length. They are perpendicular. Okay, they make a 90-degree angle. So like that. What about the angles? These little guys right here. As it applies to the diagonals, right? The diagonals bisect the angles. We're going to get some questions about that today, right? So they'll give me some parts of it, and they'll say, what is, like if they say, this is 140 degrees, do I know for sure that this is 70 and this is 70? Yes. Yes, of course I do. Now, because he is bisecting, all right? Not true in a normal parallelogram, but in a rhombus, that is true. All right, square. We know what a square looks like. He has a parallelogram, so all of the parallelogram things applies to him. What's true about the sides of a square? All sides are congruent. Okay, what about the angles of a square? All 90 degrees. Okay, what about the angles of a... The diagonals are going to split those in half. So diagonals bisect angles. And I'm going to put in parentheses, if you don't already have it in there, you can add it in, that when it splits the angles, each one of those will be 45s, right? Okay, makes sense? All right, what else is true about the diagonals? They are the same length. Not true in a rhombus, but it is true in a square, okay? So diagonals are congruent, the same length, and they are perpendicular. All right, so they make a 90-degree angle when they cross. Got it? Okay. Hold. You didn't write this down on Friday? Okay.
I stole Trevin's paper and he said,
Okay.
can you buy it if you want that?
Yeah, you can probably read this better.
Up where?
One on rectangle. Oh, all the angles are.
All the angles are 90 degrees or congruent. Yep. Okay, all right. 7-5. Here is some stuff. A rhombus. The diagonals are perpendicular in a rhombus. Underline that. Diagonals are perpendicular. That's what that one was. Each diagonal bisects the angles. Okay, that was the second little piece. So the diagonals are going to split those angles in half. That is for a rhombus, okay? Example 1, this is a rhombus. They tell you it's a rhombus, okay? Look for those key words, because when at the end of the chapter, when they start to slam everything back together, look to see, like, what is that shape? Is that just a regular old parallelogram, or is it a rhombus? I don't know. LM is the length of the side, and they label that as 2x minus 9. That is that. KN, which is this guy right here, is x plus 15. Find the value of x. They're equal to each other. Now, that was silly. That's not true for just a rhombus, but that's true for a parallelogram anyway, right? So the opposite ones are going to be the same. Whatever. So 2x minus 9 equals x plus 15. What should we move?
6.
Minus the x. That is going to be, what did you say? No. X, if I add the 9, 24. You subtracted the 9.
Keep doing that to me.
I know. I do that too. I do that too all the time, Sienna, so no big deal. Add the 9 over 24. X is 24. Don't have to plug back in, right? Okay, watch that really carefully if you have to plug back in. They're just having to solve for the value of x, so there you go. Example 2. The diagonals of the rhombus intersect all of the things. This is a rhombus. Shh. The measure of LMN. This whole angle right here is 75. They want us to find the measure of KNP. This angle right here. Oh.
When you say bisects, I just cut it in half. Right?
What? They want us to find this angle right here, and they give me this whole thing is 75.
We have to find out what the full angle is.
You have to find out what this whole angle is? How do I do that?
Minus 1.
Yeah, these two have to add up to be 180, right? Because it's a parallelogram. So 180 minus 75 is 105. Okay, so this whole thing right here is 105. Divide by 2 because it's split in half. That is like 52.5 degrees, right? Yeah? That's what each one of these is. Got it?
Yeah.
52.5 degrees. Do we see how we got from A to B on that? Awesome. Find the measure of that angle. Good. Good to go. All right?
All right.
Yes? Also, another thing that we could have done, just real quick. This is 75. Half of 75 is how much? Brady Carr, since you're running your mouth over there. What? 37.5. Thank you. 37.5. Okay. Now I'm going to look at this triangle right here. Okay. What's this angle? 90 because it's a rhombus. Then can I figure out what this is by adding these three together? Sure. Does it come out to be 52.5?
You can.
Sure you can, right? So that's another thing that I could have done, right? Okay. Lots of things. They all fit together. So however you want to do it, I don't care. Okay. Example 3. Shh. Quit it. Now we're talking square. Okay, so this shape is a square. FJ. This length right here, whoop, is 19. They want to know what FH is.
19.
38.
38.
What's going on?
Yeah? The whole thing. They want to know what FH is. The whole thing, right? Should be 38. Got it? Yes, good? Okay, rhombus and squares. Let's go down to, skip example 4. Let's go to example
6.
5. Let's go to example 6. Go to example 6. Tests, classifying parallelograms, using these tests, all the things. Okay, you're not going to like this, but you're going to do it all. Yes, you are. Okay. Determine whether this thing is a rhombus, rectangle, square, or none. List all that apply. All right, let's plot them. A is -3, 2. -3, comma 2. That's A. -2, 6. That's B. Okay, C is 2, 7. 2, 4, 6, 7. This is C, 2, 7. And D is 1, comma 3.
Yep, looks like a rhombus to me.
It looks like a rhombus?
I think it's a problem.
You think so?
I think it's a rectangle, actually.
Shut up.
Are you gonna make us do the stupid
The-
distance?
Yep, yep.
Are you serious?
I have a better idea.
I guarantee.
Okay.
you
All right, let's do this. What?
Why don't you just take the slopes of them? Just find out the slopes and then you do.
Because the slope's not going to tell me. The slopes will tell me if it's 90-degree angle or not, but it won't necessarily tell me if it's a, like,
If they're parallel,
all the things.
parallel.
Okay, so here's the deal. Let's talk about rectangle versus rhombus. Okay, I'm going to put rectangle here. Put this off to the side. This is going to be really important. Rectangle. Actually, put rhombus over here. RHOMB. Rhombus over here, rectangle over here.
We can see that it's not square.
Rhombus, rectangle. Okay, here's the deal. It will be a rhombus if what happens?
All sides.
All sides are congruent, which involves doing 4 distances. Okay, so let's do that. If I do 4 distances, I mean, you can do the distance formula here, like kind of a little bit easy here, I guess. You've got this guy squared plus this guy squared. How much am I going in the x direction and the y direction? 1 and 4, right? 1 squared plus 4 squared is how much? The square root of
Why don't you just...
17. Is this one also 1 and 4? Square root of 17. Is this also 1 and 4? The square root of 17. Is this also 1 and 4? The square root of 17. So is this a rhombus? Yes. This thing is a rhombus. All 4 sides match. Now, how do I know whether that thing is a rectangle or not?
Look at this man.
Perpendicular.
Hey, Jacob.
First of all, the opposite ones have to be the same length, right? But also for a rectangle, how about the diagonals are congruent? You remember like my husband does? He measures the diagonals to see if it's a perfect rectangle, right? Okay? So we do the diagonals to see if it's a perfect rectangle. Yeah? Okay? He's rectangular. So I'm going to go this way from here to here. I'm going to measure the distance of that guy. So this one right here, the square root of, I'm going from -3 to 2. 5, and that's squared, plus, is this a 2? 2 to 7 is 5, so that's the square root of 50. So I have one diagonal that's the square root of 50. Let's do this other diagonal. I'm going to do a different color. Okay, I'm going from -2 to 1. The square root of 3 squared plus 3 and 6 is 3. 3 squared and 3 squared is the square root of 18. So are the diagonals the same length? No. He is a rhombus but not a rectangle. Is he a square? If he's a square, he has to be a yes here and a yes here, right?
I have a question.
Okay, so he is a no.
That's what I'm saying.
I mean, maybe. But also, you could do this process without even graphing the thing, right? If you did the diagonals or whatever, like the diagonals on all four sides, what?
Why can't I not just look at it and tell you that it's a rhombus?
Because I don't trust your judgment over there,
It's your
sir.
eyes,
I
officer.
don't trust your judgment over there, sir. No, I need you to write it out, though.
I'm not going
Do
to.
the distances.
I'm gonna say look at it.
No, I'm going to count it wrong then.
That's fine.
Okay, so he is a rhombus. He's not a rectangle, therefore he's not a square, right? Can he be all three? Shh. Can he be a rhombus, a rectangle, and a square at the same time?
Yes. She literally just said if it's a square, it has to be yes or no.
If he's a square, he has to be a rhombus and a rectangle. Can he be a rhombus and a rectangle, but not a square? No, if he's a rhombus and a rectangle, it has to be a square. Can he be a square and a rectangle, but not a rhombus?
Bro, you're just confusing us.
Mrs. Gomez.
Can he be a yes here and here, but not here?
I got it.
No.
Why do we have to prove that something
All right.
is right when you can't prove that it's wrong?
I can't prove that it's wrong.
Really?
Brady,
Yes.
shut up.
I can prove that it's wrong. All right, moving on. Page 441. You guys, something else. Page 441. Let me find the paper and see if that's what I want. All the way at the end.
Go watch Frozen on your own time.
What are we on?
6, 7.
6. No. We're on 7-5. I can't read. 7-5.
That's why we have to prove the shape it is, because you can't read.
No, I'm not. Lauren's in my spot. Your spot's there. I'm not in nobody's spot.
I'm not sitting back there. I'm not.
Because she's spoiled.
No. Only one of them.
Yeah, you're too good to use this e-press, making you spoiled.
Not the second.
Not everything has to be so serious with you.
You're spoiled because you don't do any of your homework.
That's not spoiled.
Well, that's not very nice.
Oh my golly.
There you go.
Oh my god.
Like this group and this group takes no time at all. 20 and 22 take forever.
I know.
If you do it the right way, which you're gonna. Jace. I'm sorry.
I'm gonna write and look at it.
No, you're fine. You can write whatever you want. You can write this thing stinks. I don't like it at all, and that just makes it easier for me.
It says prove.
All right,
I'm gonna
whatever.
write proof.
Okay.
Look at it.
All right, do you get it all?
Yeah, Jace, that's what
1
I'm
through
saying.
10,
Why do you have to
23 through
prove that
30
shape
all,
when-
and then 20 and 22. These are gonna take not any time at all.
Why don't you just prove that it's not?
Shut up, Brady.
You did? Oh, it took you that long?
Because you guys
Okay.
don't have enough brains.
Whatever. All right. Goodbye, people watching this video. Are we good?
You guys have enough brains.
Can I close it?
Yes.
All right.
Or they're not effective.
Ow! Ow!
Hallie, do you want to start that back there?